This is stand-up EVA Apollo 15.
Okay, yep.
This is before they get out. And you can see the footprints.
Why can you see footprints before they got out?
You can see them. This is the
Yeah.
stand-up. We're going to come back. We're going to shrink this down, and we're going to take a look at this shadow right here. See the shadow?
Oh, yeah, St. George's crater.
And then here's out the window. Now, that's 6 kilometers away. And he just came down, what, 8 feet? Not even, about 6 feet, right? Out the window to out the top, right? You can still see the same depth, but you can see that the shadow has definitely moved.
Yeah, it has.
And you wouldn't see that at, 6 feet. And of course, here we've got, they've shotcreted it over again, and there's footprints all down through here, all up in here, right in there.
Yep.
That's just a couple of pictures. There's another shot of that crater with the shadow difference there compared to the first one. These two side by side there like that.
Yeah, it's quite different. Quite different.
Quite different.
Yeah.
And there's no way you're only looking at a few feet difference in there. This is just kind of a shot showing you the direction. The biggest thing that we're looking at here to start with is the direction of the shadow. The sun is coming from the east. So this should be due west. It's not. It is absolutely not. When we get into this series of photographs here, there's the diagram of it. That's north, what you're looking at. These mountains here are directly to the east on the map. So it's this direction. That's north, that's east, that's west. This photograph's taken from basically around Dune Crater here. And this is EVA 2. So that's the direction that you're shooting at. And then you have this. And you can see that. That's the same direction right there again, shooting. But you can actually see the haze of the light above that, right? So that's the direction the light is coming from. But you also have another light coming in from this angle here when you're looking at these. But that's in darkness. This is in light. And I don't care how many days you were there. This actually swings about 90 degrees. And we're going to see that.
Okay, but one question. Is this the same EVA? They're on EVA 2, I believe, aren't they?
I took all these photographs from EVA 2.
So if that's EVA 2, then that's probably maybe 4 hours difference maximum that they could have been out there.
Well, let's say 6 hours total.
Okay, how can the sun change in 6 hours?
Okay, here is EVA 2, and they're up at the highest point, right about there. Taking this photograph, shooting back to this elbow here, which is right there. And you can't see where the lem is located here because it does dip down. So it's not in sight, but that's that big elbow turn sitting from there where it swings around, this elbow here. So they're shooting from right there in this photograph. And they're still up at the same area shooting that. And there's another shot of it there. And St. George's crater is right here off to the left of them as they swing around here. And that's it swinging right around to it. Now you can see where they are in relationship to the crater right there. And then we can come back and take a look at this photograph from the lem to the crater. Kind of look the same?
Doesn't look the same at all.
I mean, the distance to the crater, it just comes up the hill. There's the crater. This is a stand-up EVA from 6 kilometers away. They're way back here. This one is taken from right about here on the map. This photograph right here is taken from in here. That's the track going up to here.
See, those tracks don't even look right. They look like small model tracks, don't they?
When you look at this rise up to here, to the crater, from this distance, this is 6 kilometers away to the crater, and this is very close to it.
Yeah, that's something not right there.
Yeah.
Look at the detail that you're looking at all the way out here, and the same detail in the dirt looking out here. Like you come up to the Kubrick line, right? There and there. There's not much difference. Like this crater and this crater are a bloody match.
Yeah, those two are, yeah.
Yeah, and this one, I imagine you're just standing closer to it right here and here when you're shooting that. But the difference is on the map, you're shooting from here up to there, or you're shooting from back here, okay, which is 6 kilometers up to the edge of the crater from here. And here it's about 2 kilometers up. So how can you have these two photographs like this? They're on a very small set.
Yeah, you are. There's something very odd about the perspective on those.
You wouldn't be able to see any detail out here. And as a matter of fact, if you're 6 kilometers away, the curvature of the moon would drastically impair your visibility to this surface, right? The curvature, what is it, 1 mile or something you can see on a flat surface?
On a flat surface, about 2 miles, I think it is.
The only way the sun can change that fast is if this was taken on the Earth and then a polarized lens was used to get rid of the blue sky. I don't see any other way they could have done this. It's so well lit, it has to be lit by the sun. There's no way you could put artificial lighting in there. It wouldn't work.
No, as soon as they're on the rover, they're out on a set. And that's why you get such swings in the...
But I mean, look what Jack White did. Just doing that polarization technique, he got rid of the entire studio,
Yeah.
minus those 3 tiny little dots for lights up there. But he got rid of it all.
Yeah.
He made the whole thing black. So why
But
couldn't they
right-
have done that?
Right
Or-
here, fully shadowed over. That is coming in from the east.
How long would it take the sun to travel across the sky, apparently, to produce that shadow? That picture there you've got now shows no shadow on that mountain.
If you watch, it's starting to swing around to here. It's going to come around to the south. This is EVA2. So you can only have a total of 6 hours, but you can't go from the east to the south. And you can see it starting to swing here already. It's still from the east, but it's now from where he's taking the picture of. He's out here. He's right out here at the far edge of this, shooting back to here, which is there, right? So he's up there and it's still coming from the east. And then you come around and you start to look at these shadow lengths that you're going to see here. Here we are back here with the rover, and it's back in the shade before they left, right? It's still shooting from the east. Now, here we have another shot where the sun's got quite a bit higher, obviously. And this is the same shot up to St. George's crater. No shadow. You can see right into it. There's another shot at the end of EVA2.
Still showing no shadow.
Yeah. There's the first shot of 87. And once again, we're in orbit. And there's reticules on there, which the cameras were only, with reticules, were only used on the surface, right? This magazine starts out in orbit.
They have to be in orbit. They can't be down there yet because the reticules are on that film, which means the cameras have not been left on the surface yet.
Right. This is at the start of it. So as you're watching here, you're going to see the CSM is going to descend to the lunar surface.
What?
It's going down towards the surface.
Maybe it's going toward that big, huge city on the horizon up there.
Right. And then we get these plaster molds, whatever they were doing. They do this with these couple of plaster maps that they're looking at here.
That crater there that you just shown, the one with the island in the middle,
Yes.
that's Tsiolkovsky crater on the far side. It's the only crater like that on the moon. And we know exactly where it is. It's right round about. You can't see it from Earth. You can only see it if you're allegedly in lunar orbit.
Yes, and that's the one that Artemis should have been taking a photograph of. It should have shown this type of terrain, and it showed none of that. Now we get some stand-up EVA here coming around, and the sun is definitely to the east. This is Hadley Rill here as it comes around. And of course, that is completely blacked out, fully shadowed over. And then we come around and you can see where the light's coming from. But that's how you get that angle on it. And of course, this mountain here in the video, because it's bouncing around on the camera, they were saying that that was an alien spacecraft that was flying by. There's the experimental equipment. It's 500 feet this way from the limb. That feature there is the north complex, and there's the shadow.
Well, the shadow's going towards the ridge.
The sunlight has gone from the east over top, covering over the south cluster, which is actually on the east side. But that's pointing straight up there. That's the north complex up there. There's the limb, and the experimental equipment is 500 feet this way from the limb.
And the shadow of the limb should be pointing in the same direction.
It should be pointing towards Hadley Rill.
Yeah, it should be. The sun on the moon moves much more slowly than it does here on Earth. It takes, 14 days to travel from one horizon to the other? Well,
I'm just swinging around here. There's where the sun, so-called, is coming from as you come through here. It's still coming from the southeast at that point, right there. That's southeast. But it's lit this up.
it shouldn't be doing that.
That's due north right there.
There's something very wrong with the angles in these pictures.
Hadley Rill is over this way on the photograph, and that's the north complex right there that you're looking at. This is now down at the experimental equipment. That's the north complex that runs across here.
Then the sun's turned at 90 degrees. If you look at the shadow in St. George crater and compare that to that hill when it doesn't have a shadow, that's a 90-degree shift in the sun in a matter of what, 5 hours?
That's pretty much due east right there. And the sun has swung around, not quite due south, fairly close to it. Like due south would be just over here, and it's there.
Yeah, somebody's got their angles completely wrong on this.
Yeah.
In trying to relate the sun position with the sun angles throwing shadows on the surface.
And you see, of course, Hadley Rill is just in behind here as it swings around the crater right here. That's magazine 87.
So from the landing of Apollo 15, allegedly on the moon, how long did they spend on the surface?
They were there for 18 hours and 37 minutes total time on the surface, and they traveled 17.5 miles.
So the sun on the moon, assuming this is what we're looking at is the moon and not some model of it, would move about 30 degrees in total.
Yeah, but it would still be from the same direction.
Oh, of course it would, yeah. And that's what's missing, that the direction of the sun is not correct in many of the pictures.
But you see here, just to show you where we're at, this is their high point on this spur here. They're up on the spur. St. George's crater is to the left here, and then when it swings around, there is, from this shot here, about 2 kilometers up to the elbow. And that's swinging back around, and of course, it's still EVA2. There's the sunlight is off of it again.
Well, 18 hours, that's Earth time, isn't it?
Yes.
Yeah.
That would really not show very much change of shadow angle during that time, allegedly on the moon.
And then they were out there for 6 hours or so. So if you give them the benefit of the doubt and they were out there for 6 hours, that would mean that there's no way that sun could have moved 30 degrees in that amount of time. It's not possible.
Here's the shot shooting down to the elbow here. For that shot to be taken, it can't be taken from here. It has to be taken way over here somewhere. And it's not from here. This is EVA2.
And that doesn't show the lander in the picture, does it?
There's actually one here where there's something shows up. If you take a look right there, we're going to see something show up right here. That's not the LEM. The LEM is back on the first elbow up, and you can't see it because of the terrain.
Well, that's convenient, isn't it?
But you see it's swinging around here. It's showing you their high spot when they're up on the spur where they're taking all these photographs from.
Yeah.
Just so everybody has a reference point of where we actually are taking these photographs from. That's Dune Crater right there. So here they are here, taking these photographs.
The Apollo 15 second EVA time was 3 hours and 57 minutes. That's how long they were out there total for EVA 2.
So here they are at Dune Crater shooting up, so you know the reference point of where they're going. And then all of a sudden, they are at Hadley Rill, right here, which they're back just in front of the LEM when they're shooting that. And I don't know how you can get this far away from it and then back up close to it again. Well, that's it in there. That's the mountains behind it. When you start to look at these images that they put in here, it just looks like a background map to me because there's absolutely no detail in there. Now, does this look anything like this? I mean, this is just a plaster map.
Their shadow angles are not particularly long, are they?
Well, it's not that. Look at the distance between there. This is St. George's crater here. And what's this one? I mean, there's two craters here. They only show one. They show it, what, half a kilometer away from here?
Yeah, about that.
How far is that then? Like, this thing's a mile across.
Well, that's what we're told it is. It doesn't look a mile
Right.
across.
So you're at least 5 or 6 miles back to this crater, and then this is the one that's up on the edge.
But if you compare that to the map on the left there, St. George's crater is shown as being quite close and much wider than Hadley Rill.
Yeah, and you're missing this one, unless they're including that. So you're missing this one, you're missing this one, and I suppose that's supposed to be Dune Crater over there.
Well, if that's correct, then the shadow angle shouldn't really change very much in that time.
Nope.
Well, these shadow angles are coming in this direction. But when you're looking at the distance, if that's a mile across, then how many miles is that? 5 or 6 miles? Good 6 miles there. Could be 7 miles to this one.
Yeah, they got the perspective all wrong. That rill is not a mile across.
Well, this is supposed to be a photograph before they landed.
It can be whatever you like, but it doesn't mean to say it's real.
Look at the shadows. Like, how many times did they go there? They came in, they landed, they took this photograph. The sun is the opposite direction. Where is this mountain range over here? Where are these mountains? On this side. They're right there. If you look on the map, where the LEM is sitting, straight back from there, straight back from this little clip, so it should be sitting about there. And when you turn around in the photographs, you got a great big mountain. There are up here, that's the North Cluster. That's the North Complex, that one right there. But it's way the hell up there. When you see it in the photographs, it's only like here. But there's nothing here that are in those photographs. How could this be out of perspective? This is supposed to be a real photograph. This matches closer to what they were taking photographs of. But this doesn't. The sun's coming from the opposite direction. How does that happen? Well, there's your sun angle right there. There's the angle that it's shooting at right through there. It's shooting at that angle there, and then it's shooting this way here.
All right, but then the shadows should not be on the opposite side of the rill then.
No.
Well, you can see it here. You can see it here.
Right, but look at the opposite side of the rill. The shadow's on the opposite side now.
Yes, because the sun's coming from the opposite direction. Now it's coming from the west in this photograph. This is supposed to be a real photograph.
If that's showing roughly where the LEM set down, it looks fairly flat at this point.
Right in here somewhere.
Yeah, right in there somewhere. That looks quite flat. That's why I question if it's being photographed from the spur, which is near to St. George's crater, that you wouldn't see it. Of course you'd see it. It's 20 foot high.
Actually, from here, there's a ridge in here. There is a geological map that shows you that when you're up in here, when you're up here, you don't see it, and when you're up here, you don't see it. But here they are with reticules on there. Like when you're looking at these windows, this is the CSM. It definitely didn't have reticules on the cameras there. The cameras that were left on the lunar surface were in the LEM. And here we are coming up to dock to it. And then we're back around the far side of the moon again. Quite different looking crater again, isn't it?
Yeah, it is. Yeah, quite different.
But we know it's the same crater, right? That lovely Russian named crater. But here again, when we're back down on the surface here again, this is 92, this is EVA2. Again, here they are around the equipment, and you're looking at the distance from there, straight up there. The LEM is this way.
Yeah, that's pointing west, that shadow.
Okay. So now in this photograph, this equipment is set out here is to the west of the LEM. And when we looked at the other photographs, we could see the North Complex above it. That's to the north of the LEM. And like I said, we should have been looking at Hadley Rill in those other photographs. And here again, it's another direction. How many times did they practice this, and how many times did they go out and redo this. It's quite obviously what you're looking at in the background, right? Now, when you come to here, you can see the shadow, and there's the North Complex. In this photograph, that's the North Complex, and we saw it on the big map. West is that way.
Something very wrong on these pictures. It's like they wanted to get pictures, but they didn't really care if they got the sun angle right.
It's all over the place in this one.
Yeah.
Absolutely full 90 degrees off at any given time. Plus the orbiter one is the exact opposite direction. And that's what I say when you keep going through, and there it is again. If the equipment is west, the only thing you're going to see is Hadley Rill.
Yeah.
And there are some mountains behind that, but you're going to see the rill. And you don't. You're looking at the North Complex. There it is straight up again. And then where is this in that orbiter map? Where are these in that orbital map? They aren't there.
That's the south cluster there.
Yeah, I don't know why they call it the south cluster, because it's directly to the east of the map. That's north.
Where is the south cluster then in that orbital photo? I don't see it anywhere. It's just gone. I mean, at least we know how far it is away from the LEM.
Yeah.
Point the LEM out so people can see.
Straight about there.
Then where are they?
They aren't there. That's the North Complex. In this photograph right here, the shadow is going towards the rill, because he's out at the experimental equipment in it.
Well, now the sun's on the north side.
Which would be right there. Now the sun's coming in almost southeast, actually.
Well,
And this is mostly west.
so where's that hill?
Oh, it's not here. Yeah, but you see when you pan around, that's these hills down in here. They're actually over here. And look at how close they are. Now we're going into these big hills, which is this hill here. Look at how close that is. It's way the hell over here. It's 7 or 8 miles away as it's coming here. The perspective's right off. And this is coming into this crater right here. There it is there.
Hill,
We're looking at these
right?
hills here, and these are missing, and these are missing.
The perspective is so off on the picture on the left side there. I wonder if those hills are actually out further on the right side and you just
I
can't
mean,
go
way
that.
the hell out here? Oh, they're just
Oh.
nice and tight, just like this guy is. They're not going back anywhere. They swing right around and come this way.
Basically, they're boxed in by those mountains then.
Yeah, and you don't see that anywhere here. Don't forget where the LEM is. The LEM is way the hell back right there. These come around like this and back past them. Actually, well past them as you go through. See, and then that one.
Yeah, where is that one?
Oh, it's all missing. All of it's missing. The photographs have no relation to this whatsoever. This is just a plaster mold that is very poorly done. The perspective is so far off on this, it's unbelievable. The lighting is the exact opposite direction. That's how bad it is. And they're trying to pass this off. 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 Off.